yeah, go to more events for that this week. It's happening, and we'd love to make sure that everything is really well attended. Again, thank you for coming, and thanks to MX for sponsoring. Is Garrett here? Garrett's our MX representative. Everyone tell him thanks at some point tonight. Beyond that, we're really excited to have Cameron Bell speaking today about practical ML. He's our speaker. What else? We have Forge Slack. Everybody join the Forge Slack if you're not already a member. And that's about it, I think. Are we ready to get going? Are you guys feeling good? Yeah? You like the pizza? Sweet. Thank Garrett for that too.
Thanks. I'm sure it's going to take me a minute to get sharing my screen and everything, so still have time to eat your pizza. That's what I'm saying.
While you're getting started.
Sure. You don't need audio here, do you?
No audio, just. Hey, guys, thanks for coming. I'm Mariah Peterson. This meetup is part of the family of Forge Utah meetups. So if you're technical and want to do more tech things, we've got a data engineering meetup, a Go meetup, Kubernetes meetup, this meetup, engineering leadership. Do we have more meetups? Oh, we have Todd's Hack meetup where we get together and hack on things twice a month. Like if you just want hands on keyboard, there's that one too. So, and then we have obviously the Slack channels where we talk about it when we're not in the same room. So it's just forgeutah.tech. There's your webpage. Click the join Slack link and then join the machine learning channel and the random channel and the keyboards channel. And I think you're probably good. And with that, I'll stop talking and you can listen to the good content.
Okay, thank you, Mariah. And thanks to everybody who hosts this and keeps it running. We've had a lot of good meetups in the past, and I think it's certainly helped my career a lot to network and learn from people. So big thank you to everyone involved. So my name is Cameron Bell. I am a data scientist. I started my career around 2015, studied physics and then data science at physics at BYU, and then data science at UC Berkeley. And I've been doing general purpose data science in e-commerce and fintech at 1-800-Contacts, and also MasterCard, and also had a few startups. I'm going to talk about a couple of those today. So the general trend that I see in AI circles is we like to talk about the fun stuff. We like to talk about the cutting edge. We like to talk about what makes headlines. And if you were to read any sort of AI newsletter or business newsletter that has an AI section or a tech section, you're probably going to hear a lot about LLMs right now. I haven't seen a whole lot of people actually make a lot of money from LLMs. I think that's going to happen, but we like to talk about what's in the future. And I think sometimes we get lost or we lose the more practical stuff. It's maybe more boring to this audience, but I thought it could be helpful because I've been on the applied practical side. So we're going to talk about AI for fun and profit today. So like I said, AI is this magical word. You might have heard the running joke that's gone for the last decade or so, that if it's written in Python, it's machine learning. If it's written in PowerPoint, it's AI. Because AI has this magical quality to make people's eyes pop, and you think, we don't know how it works, and that's why it's so great. That's why it's so amazing. Well, it's also why it often fails in the business, in the market, because When you don't understand how something works, it's hard to use it. So LLMs, large language models, they have advantages. They get people interested. They are interesting to talk about, and they look kind of magical. The way they work, even to a lot of data scientists, it's pretty mind-blowing how they work. I'm going to talk today about MMMs, money-making models. They are boring. They look like something that you learned in your first class. Maybe it was a cursory class or even a small unit of a statistics class or a computer science class. And you think, okay, well, this is just scratching the surface, doing a regression model. This is just what I learn on the way to learning an LLM. Well, in reality, it might be the most useful thing that you ever learn. And knowing those fundamentals can be very helpful. Dylan Skinner is here today. He's doing a great series on his blog about some of those foundational, simpler, well, not simple, but older, more boring models. And that's the world that I work in largely. You can always look to LLMs and the next fun thing, but what I want to encourage you to do is to do simple things thoughtfully. Start with something simple. Does it even need machine learning? That should be your first question. Okay, this is the problem we're trying to solve. Now, a lot of data scientists, I totally understand. If you are starting out in your career, then your first thought is, how do I become a respected person in my field who has credentials of some kind? There's no bar exam, there's no boards to pass like in the medical field. So when somebody says I'm a data scientist, it can mean all sorts of different things. So in my first job, what I tried to do was I took on every project that I could, all different kinds of machine learning. I did computer vision, I did classification, I did some regression, some time series, some recommender systems, so that I could prove, hey, I've done this. And that's fine if that's your interest. But if you're trying to make money for your company, generally do something simple. Okay, so we're going to start by choosing a project. This is actually how I landed my first formal data science job. I went in for a conversation with a colleague. I did not understand that it was an interview. Actually, he had about 20 data science projects, prospective projects listed on his whiteboard in his office. And he said, well, these are the things I'm looking at doing. We're thinking of, starting some data science here. And I said, well, that one's impossible. That one's impossible. That one's going to be super hard. That one's going to be really hard to implement. Do you have the data for that one? That one looks easy. That one looks great. That one looks awesome. And he was like, okay, well, can you do it for us? And I was kind of caught off guard. And I said, well, sure. Yeah, great. I'm looking for a job right now. So that would be awesome. Since then, this is not original to me. I forget the speaker that I heard this from. You might have seen this framework before, but this is very helpful for deciding on a project to work on. So on the y-axis, we have impact. How much will it help the organization? It might be financial. It might have other impacts. And feasibility is, how easy is it? Well, not how easy is it for you to do. How likely is it that you will be able to actually execute on this well? So let's go through a couple examples. Conduct sales calls with an LLM. Okay, so to actually replace a trained sales professional who has human connection and knows how to knows how to navigate a sales call and knows your product inside out, you might be able to get the words sort of right with an LLM. There is no way that you're replacing a sales professional. However, the impact would be incredible, right? You could run sales call after sales call. It never sleeps, never stops, costs nothing. That would be incredible. But there's no way we're going down that path. On the other side of the spectrum, let's run sentiment analysis on product reviews. Okay, well, yeah, we can plug in an NLTK package and have sentiment analysis done for us, in 20 minutes or less. However, we already have 0 to 5-star ratings on them. Is this really going to help us? I don't think this is going to generate any revenue. It's not going to help us. So let's pass on that one. Then we have something like using an AI agent to order the CEO's coffee at the time that he wants it, with exactly the amount of cream and sugar that he wants. and from a different place every day that, you know, tracking his every movement, making sure we get the right coffee, the right size at the right time, optimized for him to be awake for his sales calls. Well, yeah, that would be cool. It would be really hard, and it also wouldn't matter. So this is the example that we're going to go through a little bit as a proxy for just the framework of practical machine learning. And this is a project that I worked on years ago at 1-800-CONTACTS. At 1-800-CONTACTS, they are an online retailer of contact lenses, and they their main competition is brick and mortar stores, where you go. It doesn't look like a store; it looks like a doctor. You go into an optometrist. By law, you're required to renew your prescription, and they say, "Hey, while you're here, why don't you buy some contacts from us?" It's a sneaky thing that always really bothered me. And so what we lose at 1-800-CONTACTS, what they lose most of their revenue to is customers who regularly buy from them, and then they go to an optometrist, and the optometrist steals, 4 months of business from them. So what if you could know exactly when they need their contacts, right when they're about to run out, you send an email to them and capture that order before they go back to get that eye exam. And the best case scenario, they already ordered it, they go to get the eye exam, they say, "Hey, why don't you buy contacts from us?" "Oh, I already bought them because Cameron in the data science division knew that I was going to need them." So that would be huge impact, and it's not at a 9 or 10, it's still unpredictable human behavior, and the timing is very challenging, but that looks like a ringer. So let's go down that path. Okay, so the first thing that we're going to do is we're going to establish a baseline. What are we doing already? What's the status quo? What do I have to beat? Is there maybe a heuristic that I can use? Well, in this case, there's already a heuristic. They have this thing that they call the do ratio. So let's say if you have monthly lenses, and you buy 6 packages, so 6 months worth of lenses. Well, then we're going to take the days since last purchase over the recommended wear time. So you bought 180 days of lenses, and it's been 170 days, then you're going to buy in 10 days, is the intuition. It's a pretty good heuristic, and we'll actually look at real examples of this. So that's what we have to beat. We have to be more accurate than that. Okay, so then we're going to try to do a little bit better than that. Is there a heuristic that's better than that? Probably not. That's pretty good. So we're going to start with something that works out of the box. That's going to take, this step should take, an hour. You put the data together and you throw it into a model and you do everything you're not supposed to do in data science, and you just see what comes out. How good is it? Is it good or not? Obviously, you want to make sure that you're not cheating and you're not letting the model see into the future, have any leakage, something like that. But you want to establish a baseline. Is machine learning out of the box going to improve on this? That gives you a really good idea. Okay, so in this example, this is real data. Not everybody wears the manufacturer recommended amount. So some people get daily lenses. Like myself, I buy daily lenses and I wear them for 3 days, and it works great for me. And my time at 1-800 taught me that the plastic really isn't that different, and so the dailies are a lot cheaper that way if you wear them that way. So I would be over here. I have a ratio that's over 3 or around 3. Some people are part-time wearers. They only wear them at social events. Also me. When I'm at home, I wear glasses. When I'm here, I wear contacts. So there's this big bucket that's like impossible. It's so hard to predict. And then you have people who, for some reason, throw them away before they're supposed to, or lose them or something. And then you have people who either wear them longer than they're supposed to, or they're part-time wearers. So we're going to dig into the actual data and see what we can find. I'm going to skip over why we did a classifier instead of a regression model here, but it was simpler. Going back to the theme, do simple things thoughtfully. So we went to buckets of this ratio instead of trying to get a complicated regression model that has, such and such error. It was easier to lump them into buckets. I'm not going to get into what this is because partly I don't really remember, and also it's more complicated than the scope of this talk. But I will tell you briefly, this is a time scale. Each one of these boxes is a customer, a unique customer. Each color represents a different type of lenses. So blue is, I believe, bi-weekly lenses. I think purple is dailies, and then orange is, I think, the gaps between where we assume that they went to an optometrist and bought some. And the height represents their stretching ratio. So how much longer did they wear them than their manufacturer recommended? My point in showing this is not to teach you about contact lenses. It's to show you that we actually sat in a room and talked about this for a few hours because a thoughtful representation of the data led to some serious light bulbs for us. And seeing real examples showed us, well, hey, maybe we're missing something. Maybe we should look at this. Maybe we should try this. So you're not going to find this plot anywhere in a data visualization book. You're not going to find it in a statistics class. You're going to find all sorts of different ways to represent data, and that's great. But think about your specific use case and think about if there's a way that you can represent it that might be helpful for you to get some insights. Okay, so let's talk about feature engineering, the secret sauce of machine learning, in my opinion. Any data scientist can throw together a notebook and try a few different models, but the really good ones know their domain well enough to create intuitive features. Let's just look at like two of these. Days of supply. So that is how many days are left on the manufacturer wear time. It's pretty intuitive. It's a small one, but that goes in as a feature to a random forest model. This is the standard deviation of their historical stretch rate. And then surprisingly, it doesn't matter that much if they're a daily wearer or a monthly wearer, or if they've been relatively consistent in the past. They're just not very important features. So that's one of the reasons, by the way, a random forest model is so good to start with because it gives you visibility into what's important and what's not right out of the box. Okay, then we get to the actual modeling and evaluating those models. So I wish I had a better graphical representation. I used MLflow when I was at 1-800-Contacts, and I didn't save all the data artifacts. If you're not familiar with MLflow, or there are many alternatives, weights and biases is another that I've used. It's a framework for running experiments and saving the results. So what you can do in this case, if you're going to try a bunch of different models, which, by the way, I included do ratio here because that's what we're trying to beat. That's our baseline. Then you can track all of these numbers and then compare them all at once. Let's say then you want to try, what if we changed, days of supply? Actually, this one, I don't remember how we computed days to next order, but this one here is days to next order squared or something like that. It had some relationship to it. So, hey, we've got this idea that maybe that mathematical relationship will be important. Let's try it. One of these platforms like MLflow will help you to organize those experiments. And we'll talk a little more about that in a minute. Okay, and then just like we had our weird visualization of the actual data, we want to look at a visualization of the model itself. So what I'm comparing my model to what happened, right? And I can look at metrics. I can stare at this all day and fall asleep and probably not understand it. I'm sure many of you here intuitively understand statistics better than I do. But when I look at one of these things, I'm like, I guess I sort of understand what that means. I want to improve on it. I can see that this model is better than this model, but it doesn't really mean very much to me. This means something to me, and I can communicate it to stakeholders. So this is just a histogram, counts. So how many, remember we built a classifier that put them into buckets. How many of the ones that we predicted to have a do ratio of 1 actually did? Well, it's overestimating that they're going to be consistent. Certainly a lot better than the do ratio itself is, because it would just put all of them there, right? We're predicting a lot of outliers and they're not actually happening. Maybe there's something that we can do to tune this to make it a little more accurate. Okay, here's another one that's a little interesting. This is our comparison right at the heart of what we're trying to do. We're trying to beat the baseline. Now this is an error plot of the different quantiles of predictions. So how far of all the predictions, how far off are they? Well, we've got do ratio has in the 20th quantile has this much of a negative error. And our random forest model outperforms it dramatically. You can see from here all the way to here, it's outperforming it. And this is the absolute value of those, which is maybe a little more intuitive. So you have less of an error all the way up until the 90th percentile, and then about equal until the 95th percentile. So that lets me go to somebody who is not well-versed in statistics and say, this is a better model for 95% of our customers. You can see that it has less of an error in every case. However, we pay a price. 5% of these customers get a poor result. So can we maybe do something to keep those errors from being too extreme? And part of the reason for that is just a mathematical reality that do ratio is always right in the middle. So it can only be a certain amount wrong. If I'm going to predict something over here, it's way more wrong than something over here. So anyway, a couple different ways to represent it. Okay, so what we want to do with those experiments is we want to hypothesize. We want to say, I think this model will be better, or I think this feature will be an improvement and add information that the model will find useful. Or I think if we clean this data set, or if we use this data set instead, or if we use this subset of customers, it will improve this metric. Write out your hypothesis clearly, like a scientist. Then go experiment on it and see if you can prove it or disprove it. Afterward, and track what you're doing. Afterwards, analyze whether or not the hypothesis was correct. So I'm going to go through, let's see. Okay, and this works for features. Try different or new features. It works for models if you want to try a different modeling framework. It works for hyperparameter tuning. I like to do a random search and then a grid search once I get to a fine area. I like to run these experiments, store the results, and then I can know. And I can know forever. I can always have a record for it. It works for choosing a different data set. This framework has really helped me to build something useful. Okay, and I'm going to show you sort of an example of this. So this is an example of an image that we classify at a startup that I've been involved in for the last 5 years that classifies, finds and classifies parasite eggs in patient stool samples. So this is a microscopy image that's been stained and put under a microscope. It's relevant in the third world, and we've had some success in the Philippines doing this. We've outperformed doctors actually with our model, which is really cool. I'm not so involved anymore because I've moved on to a few other things. But in the pursuit of this, we have run in the last year or so. We've run, looks like now 40 models. Now, one way to do this is like the poor man's version of MLflow, where you're tracking each model. This has, some of our parameters. What are the warm-up steps? Which data set did we run it on? Did we grayscale or did we have color? Did we, this is when it trained, what it trained on, how long it took, and then how many steps we have it run, and any notes like this didn't really work, or, and then somewhere in here, oh yeah, okay, here we go. We don't always put it because some of the models just don't even work, but we have some objective measures here, like a map. If you work with computer vision, it's a pretty good all-purpose metric that you can compare. Okay. And then wanted to show you how TensorBoard looks. Oops. So we use TensorBoard to track these. And this is over time. The x-axis is over time. The y-axis is a map, which is a general purpose accuracy metric. You can see that over time, each one of these lines represents a model. Over training steps, they get increasingly better and better. Sometimes we run it for a while and realize there's no chance it's going to keep up with the best models. But this is what it looks like. And this way I can go through and I can say, okay, model 14 is outperforming in this way, and this way. I can look at different models or different metrics on here. One cool thing about TensorBoard, which I don't recommend TensorFlow for any reason whatsoever, but one cool thing about TensorBoard is that you can also see the images themselves as they're trained and as they get transformed through your process. If you're using like a CNN and they get transformed. We use TensorFlow, by the way, because our specific constraint was to get our model on the phone working without any Wi-Fi connection or data connection, because somewhere, out in a poor village, that's not reliable enough to use. So getting a model like that, a computer vision model, onto the phone is very challenging. And TensorFlow had just enough documentation on how to do it that we went down that path. But hopefully PyTorch is going to someday release their PyTorch mobile from beta and it'll actually work. Here's a screenshot that I got just from the internet. Won't spend much time on it, but this is how MLflow works, just to give you an idea, right? So these are different experiments running, I guess, this one, and this one. You can compare them. You can look at, there are 3 of them. 2 of them use the same data set. There are 2 different data sets. They have different learning rates. They have different training sizes. And then this is the outcome. And you can actually look at how they did. It's kind of a cool way to do a multivariate analysis, but okay. All right. A note about institutional buy-in. So Eric had a great post the other day about questions that you should ask in a machine learning interview. I really appreciated it. Some of those, it got me thinking about how to get yourself into a winning situation. One of the ones that you had in there, Eric, is machine learning core to the product, or is it ancillary to it? Are we analyzing it for better sales, or is it part of the product? Super important context. That doesn't mean that it's not important if it's not part of the product, but if it's part of the product, you are going to have the institutional buy-in that you need to get it, to do the development you need, to get the resources that you need to, once you actually have a mathematical success, turn it into a business success. I have had the unfortunate experience of having mathematical successes where the model works better than the status quo demonstrably, and I don't have the authority to then go implement it. It's very, very frustrating. So another good question is, who owns the data science initiatives? Who is actually proposing them? And do they have the authority to go to engineering and say, here's a model, go ship it? Am I going to be the one shipping it? And if I'm the one owning the data science initiatives, then I should be the head of machine learning, shouldn't I? And if I'm not, then something organizationally might not be right. There might be some discussions to be had about the organization. And then lastly, after you have come up with a model in the lab that you're confident with, run a small test in the real world, and that will help you to increase your confidence and your leadership's confidence in implementing it, because you can say, well, this worked for this subset of customers. This worked in the real world. Okay, I have some things to say about a startup that I'm working on after this. I wanted to pause for a moment because I'm definitely going to forget to put this back on the screen after I talk about that. But yeah, please connect with me. I am happy to be here. I'm happy to talk with you guys, and there's a lot of interesting things going on in this room. So, all right. So I'm going to set the stage for what I'm going to talk about next. Mariah, timing wise, when are we hoping to wrap up? Okay. Well, Tyler over there was falling asleep, so I'm just worried about him. Okay. All right. Yeah, I'm going to talk about that for a minute. So okay, so if you've been following anything in AI, which I would assume you have been, or you probably wouldn't be here, then you have seen some pretty mind-blowing images coming out of DALL-E, Midjourney, Imagen, and whatever other off-brand interesting models come out of companies. And then also from the open source community, we've seen Stable Diffusion has done like some mind-blowing stuff that looks real. And Chris, you recently posted about how people cannot tell the difference. They think they can. That's actually the worst part. Some recent research shows that people both cannot tell the difference between an AI generated image and they think that they can. That's only going to get worse. I hope that most people realize as we go forward that they cannot tell the difference. But back in 2022, I had just published a children's book, just a passion project of mine. And I saw what was coming out of DALL-E, and I already knew, GPT-3 had been playing around with it for years. And I thought, well, wait a second, I could probably, what I just did over a period of like months and hiring an illustrator and all this, I bet I could do that in like 10 minutes with it. At the time, it was kind of cool. Now, with ChatGPT, everybody's done stuff like this, but I actually published a book. It's called This Book Has No Author. This was before ChatGPT came out, and I thought people would buy it as a novelty for Christmas or something. It's written and illustrated by AI, and it was just kind of fun. And then once I put it up on Amazon, I was like, well, wait a second. This is freaky. And you've probably had some of the same thoughts, especially if you've seen like a political figure or a current event misrepresented by something AI generated. A couple of friends and I started talking about this and trying to figure out a way to show that something is real versus AI generated. I'm going to fast forward to the end. You can't tell if something's AI generated. It's impossible. There are ways to get close. There are ways to get an estimate, but it is, in my opinion, totally impossible. So we have changed our outlook to be a tool that shows you that something came from a party that you trust. And that's it. We can't tell you if it's real. We can't tell you what the truth is. We can't tell you who to trust. We can tell you this came from the White House with 100% certainty. So we have here are a couple examples of problematic material. These are real ones. This was used in a Ron DeSantis campaign. Never happened. Trump embracing Fauci, for those of you who can't see. We had Tom Hanks. He came out and endorsed a dental plan because that's what he does and totally on brand for him. So he then had to go on Instagram and say, hey, there's this video floating around. And I actually think the reason he did that is because they're using some generative AI in a movie he's working on. And he was like, didn't want it to look bad. This is a generated image of Jerusalem that made it to newspapers. It was in real newspapers. This did not happen. That bomb never exploded. That cloud of smoke never existed. Now, all sorts of other things are happening in Israel and Gaza, right? And this just makes it harder to know what's actually happening. It's terrifying. So I also put on there, AI's created more images than the entire history of photography. I wrote this like 6 months ago. Like, That is insane. It took about a year, and all of photography surpassed. Okay. So some of the solutions we have are AI detection. You can use models. Some of the models are actually trained alongside the generative models, and you can borrow from those. You can do some transfer learning with that. But the problem is, they are not 100% reliable. They do better with video right now. The leading way to do it with video is to look for veins pulsing, apparently. And it's interesting to me that deepfakes haven't picked up on that yet, but they're just not 100% reliable. It's going to get harder and harder. You're always playing catch up because people are more motivated to build the next really good generative model than they are to build the next detector. You're always a step behind. Next time the new one comes out, you're obsolete. They're also expensive. You can't run every image on the internet through a GPU, every video. It's just completely implausible. Then we have digital watermarks. So these are, there's a field called steganography, which is fascinating and a lot of fun. And the whole point of it is to embed information in an image or a video secretly. Famously, this was used by Al-Qaeda to communicate through YouTube videos. They embedded it in the pixels or something. And they're cool, but they are fragile. First of all, almost all of them, because of the way that the life cycle of an image works, as soon as you compress it and take all irrelevant information out, you are left with only relevant information, which means that if you're going to encode a message, it's going to either be visible or removed by compression. They also can be removed if you know what to look for. You can find the algorithm that's being used and you can remove them. You can also forge them. If you know how somebody is stamping their images, say you're New York Times and you stamp them all and you figure out how to do it, well, then you can release an image and say this came from New York Times. I mean, what good is that? You might as well just sign your name in the bottom, right? It doesn't do anything. And then C2PA is a protocol that was introduced by Adobe back in, I believe, 2019. I think it's a really, really good start. It involves cryptographic signatures, so they are unforgeable, but they tend to be heavyweight. They have a fair amount of drawbacks. The main one, though, is that in the life cycle of an image, when you release an image, you license it to somebody, to a media partner or to some sort of blog, or even just put it on Twitter or whatever, it's going to be compressed. Your metadata is going to be stripped, which is where the C2PA manifest lives. You might get resized. You might get your contrast and your brightness levels adjusted. But the most common is as soon as you put it on a website, they strip the metadata. It's gone. And if that manifest doesn't make it all the way from creator to consumer, then the point is negated. So I think it's a really good start, but it generally is very difficult to ensure that it stays with the image. So the approach that we've taken is we digitally sign content. If you're familiar with cryptographic keyed signatures, this is a completely unforgeable one-way process. You take up a key, a private key, and some data, in this case, an image. We'll just focus on images for now. And you write a signature of that using the private key of the image. There is no way to recreate that without the private key. The way to verify is you have the public key that is attached to the private key in a pair. So anybody can take the public key and go verify this actually came from the New York Times. Then we take that signature, we put it on the blockchain, and I'll talk about the actual architecture in a little bit. It's evolved over time. And what that does is it timestamps it, and it gives us a few other advantages of being an open protocol. And then because everybody has the public key, you can go find the image and verify that signature. So this is pretty much exactly what I described with C2PA. The difference is we put the signature on the blockchain, let the image float around, get folded up, crumpled up, coffee spilled on it, stamped on, thrown in the street, torn up. And then when you pick it up in your weird corner of the internet and it still kind of looks like the original, you do a reverse search process to get back to the original. And now you have the signature on the blockchain and the original image, no matter how it's been compressed or changed. As long as it hasn't been changed materially, meaning it represents something else visually, at which point it is a different image, then you can connect it back to the original and verify that it came from where it purports to come from. Okay, so how do we do that? Perceptual hashes. A perceptual hash is like a cryptographic hash, except it is intended, if you take, let me step back to cryptographic hashes. If you take an image and you sign it with your key, and then you change 1 pixel, even just 1 byte of difference, and then you sign it again with that tiny difference, the 2 signatures are completely unrecognizable, totally different, can't compare them in any way. There's enough randomness that it's like a butterfly flapping its wings and causing a hurricane in Japan. A perceptual hash, however, if you make small changes, as long as it visually shows the same thing, then you will be able to compare the 2 hashes and show that they are similar images. What that allows us to do is index the images or the signatures on the blockchain by the perceptual hash. So, which connects us to your signature. So if you find your crumpled up image that's made its way through the internet and you want to find the signature, you compute the p hash, the perceptual hash. It takes you to the index on the blockchain, and then you can connect it back to the signature. Okay. I'm going to leave here and talk about architecture for a moment. But I did want to call out that when I found this meme, I realized that this is my job to find the differences between this picture and this picture. So, okay, I want to leave some time for questions. I know this is kind of information overload. It was not intended to be a slide, but it's intended to be shareable around organizations as we talk to some of our clients. So this shows effectively what's happening. We do a perceptual hash to certify, sign it, and we'll talk about what's actually on the blockchain in a moment. And then when you find a query image in the wild and you want to know where it came from, you compute the perceptual hash in your browser, and it takes you back to that same instance. Now, if it hasn't changed at all, it's an exact match. You can get straight to it. There are a few ways to get to it if there are small differences. Okay, so what's actually on the blockchain? Blockchain storage is very expensive, so we want to keep it as minimal as possible. We want only what we need to verify. So we keep the perceptual hash itself so that we can verify within reason this is the same image. We have a link to the signature. The signature itself is not actually hosted on the blockchain. And then we have a hash of the signature so that we can ensure that it doesn't get tampered with. That shows us that whatever it was originally when it was written stays. And then you can host your signature in all sorts of different ways. Some people want to host it with us. You can host it on your own website. You can put it in S3 if you want, as long as you can link to it. And that's a semi-permanent link. And then you host the image similarly linked in the signature manifest. We've tried to make it as flexible as possible because we recognize there are probably going to be 10 different ways to do this. C2PA is one that a lot of companies have jumped on. Fox also released, they are now signing images on Polygon, which has its issues, but we really like what they're doing and might want to actually build on their architecture in the future. But if you just want a simple signature, you can do that. If you want to do C2PA and be compliant with that, go for it. So that's the general architecture. I'm going to stop here because I've been talking for too long and I wonder if there are any questions. Yes. Here, so that people on the stream can hear.
So just looking at this, it seems like the entire way that you verified is with the actual image itself. What would happen if someone got to an image first and then claimed ownership of it, and then later you like try and reverse search it? Would it not come under the original person that signed it in its name?
Yeah. Is this working? Yeah, absolutely. Great question. So if you signed it first, then you would have the first signature on the chain. That is an inherent weakness. However, I would ask, how would somebody sign your image before you are able to? And, hopefully once we get this used enough, that fear is what will drive people to use it. Yes.
What if I just uploaded an image that I had and I didn't know to sign it and someone found it? Wouldn't that be a way someone would sign my image?
Okay, say that again. If you uploaded an image,
And I didn't know to sign
you
it
didn't know to sign it.
and someone finds my image,
Mhm.
there's no signature, they can sign it. That's
Yeah.
one of the ways I think it would happen.
Okay,
So
great question. So
like
let's
the-
take a step back and ask, what fundamentally are we doing here? We are showing that this came from an entity, right? So you could say this came from me, and you're going to have an even more credible claim to it because you just signed it, right? Somebody else did not sign it first. However, the main problem is somebody posting something and saying this came from that person. This is Joe Biden actually doing this thing. Well, Joe Biden never signed it. So you might have posted a video of Joe Biden doing something salacious, but if he didn't sign it, it's like, well, I don't know. And if nobody else of, repute signed it, I guess I don't trust it too much. So it certainly has limitations. We can't tell you it's real, but we can tell you whoever signed it, signed it. So the classic example is Getty Images, who we're working with right now. If somebody comes in and says, look at this bomb in Israel, this came from Getty Images. There is no way to claim that once they're signing all their images. So it does some things well and it has holes. Great question.
So similar to like a crypto wallet, does like a New York Times have their own wallet per se that has a whole list of all these images or whatever media that people can reference back to? If that makes sense.
Yeah, so we actually are trying to do the opposite of that. So they are going to have a crypto wallet because you have to have a key to sign something and to use the blockchain, but we're going to abstract that away from our clients. What we don't want is to breach their privacy. So Getty Images has an issue with people crawling their website, finding all their images and doing things with them, right? They don't like that. So if we were to go and put on a public blockchain, here it all is, right? That causes some problems. So we're also looking into with government partners who want to sign something but don't want it available to the public until they find that image. You can use something called a zero knowledge proof, which can prove that it's actually theirs without exposing the image itself. So that way you could only prove it if you already had the image, which to some people is useful, some is not. For secure applications like government use, that's a huge thing for them. Thanks.
Thank you. Hi. That's a great technology. I love the idea. I think it's very important, and that over time there will be more and more fake AI, fake images, right? My question comes from maybe a non-technical question. It's like, so how are you gonna get a buy-in from the other entities to use your software? Because what happens if I go tomorrow and I say, well, my blockchain is the one you want to use, sign it and be on my blockchain, right? And then Joe goes and he has his own blockchain. And then you go to Twitter and you say, oh, use my software. I have the blockchain. I have the verification system, but someone else uses my blockchain.
Mm.
And how are you then you need to verify against all of the blockchains. So how are you gonna convince others basically to use your your blockchain?
Excellent question. It's a complicated solution because you have the creator of the image, You have the platform that's displaying it, and you have the consumer. And who's actually going to pay for it? Who actually cares enough to pay for it? In that sense, it's a race to the bottom for who can make the cheapest, most effective, but very inexpensive method. That's why we settled on this actually, is because you can do, I think at cost, we calculated the other day, you could do 1 million images for like $10, something like that. And so, as for getting everybody together, that is our fundamental question. We have to get the entire pipeline together. However, what you're asking is, if you can set up your own blockchain, which we're advertising somewhere on here, competitors can create their own search service based on our blockchain. Anyone can recreate it, right? And that exposes us a little bit, but it's really attractive to players who are like, well, I want to do something that's going to last. And fundamentally, I'm sure there are plenty of people in this room who could make some copy of Facebook in some version, right? I mean, it wouldn't be as good as Facebook, but like you could do it. And why would nobody use it? Because there's a network effect, right? So it's a very high risk enterprise to do something like a social network. And for the same reason, having a central, I mean, ironically, it's decentralized, but a central place where you can trust your images is very challenging to establish, which is why, unfortunately, as much as I would love to go to small players and build on top of that, instead, we are going to massive players. We have to be talking to Facebook. We have to be talking to Getty Images. We have to be talking to NBC, because if it doesn't come from them, nobody's really going to care. And I think the customary advice to startup founders of find some niche, start small, and then do that. We thought about doing that with like Solana released a phone, for example, use crypto, the crypto community, and they'll start using it. But does the crypto community have images that people care about? I don't know. I'm sure there are some, but I'll tell you that Getty Images has images that people care about. And so if we start there, then there can be some momentum there. I had a question over here.
So since the perceptual hash is open source, I, not just hypothetically, might train a network that tries to take an input image that, you see where I'm going with this? And,
Yes.
and I train it so that it makes my new image end up with the same perceptual hash as the other. So for example, maybe you would have a visually insignificant change in the image that is culturally very major. Maybe there's a change in a color on a pin on someone's coat or something that is like, for some reason, like earth shattering.
Right.
And then this algorithm might map it to say, Joe Biden posted this picture.
Yes.
That's essentially like flipping the birds of the world because of this color change.
Yes. Excellent question. I love it. We've thought about this. There was a notable example a couple of years ago. Stacey Abrams had a picture of her holding a sign, and somebody successfully put in hashtag Muslim Brotherhood or something like that, hashtag communism, without messing with the p hash that was used for a lot of reverse search engines. It's called a p hash attack. And so it's happened before. I think with something like this, it's even more dangerous than what they did. And I love that you jumped to a generative algorithm, because we thought, well, wait a second. Nowadays, like you could tell it, I want this p hash and I want it to represent this thing happening, right? So that's only going to get more dangerous. The way that we get around that is that you link to the, I don't actually have it here listed here, but in the signature itself, you link to the original image, because the cryptographic, all of this is kind of a distraction to the idea that if you have the private key and the original image and the signature, and you know who owns, or sorry, the public key, and you know who owns it, then you can prove that this came from, say, the White House, right? And it doesn't matter, oh, this comes from New York Times. I don't trust that. This comes from Fox. I do trust that, or whatever. Whoever you trust, you know that it came from that place. But by linking to the original image, that's how we get around it. It's not, the perceptual hash is only to do reverse search. It's not to do the verification or certification.
So if I see the attack image, just as a user looking on Twitter,
Yeah.
How am I going to, like in the UI, how would I find the original image?
So with Twitter specifically, we on launch day, this was our whole plan. We had built the infrastructure to have a bot that you call at bunk this, and 2 seconds later you get an answer and it says here it is. And they have that day they changed the policy from free to $40,000 a month, which, as you can imagine, was a hit to us. It's now like $5,000 a month, and they finally came out with a $100 tier, which, you know. So ultimately, we need a place to become popular, but eventually this will be a JavaScript overlay that if you want your images on your platform, if you want to be a reputable platform, you're going to have something like this. So that's how the UI would work. And specifically, let's say you find the p-hash attack one that says Muslim Brotherhood, right? You would go through this, well, you wouldn't have to. Programmatically, it would go through this, it would find the image, and then it would say, wait, this doesn't match. In fact, we can highlight, we can say this part is different from the original image. So great question. I had another one over here. It should be on, Neil.
Now it is. All right. I can see why we would want this to be open source so that people can verify that the code is actually working the way it is. I don't see why you would need it to be decentralized.
So that is because that is actually all. One of our clients is concerned that they're going to put all their eggs in one basket with a company that is 3 guys in Utah who have no funding and are bootstrapping. And what happens in 3 months when you decide to go do something different? And so we started talking with the crypto community, actually in particular a VC with a DAO, a decentralized VC firm, which is very interesting to me. And he put me onto the concept of hyperstructures, which are like public goods that run themselves. So Bitcoin is a good example of it. Nobody runs Bitcoin, but it's going to keep going. You know that it's going to keep going. Everybody knows it's going to keep going. Otherwise, you wouldn't buy it. If you thought it was going to disappear next year, you'd sell all your Bitcoin, right? But it is a public good of sorts that you can rely on. We want to set up something that is similar, where it's like this. And back to the question about competitors, you know, anybody can set up their blockchain. Yes, we've seen that with cryptocurrencies too, right? But you still go to Bitcoin. That's the one that matters. So maybe people are going to log them on multiple chains, and that's fine. But we're aiming to be the ones that do it and get the ball rolling. Do we have any more questions? I didn't see any. Really? Yeah.
You have your own blockchain, but then what incentives do you have in place to keep that blockchain continuing, say 5 years from now?
Well, that's the main question about decentralizing it, is that we won't have to, right? Any interested parties can come in and do it. The reality is, like, if you go to what's IPFS is a distributed file system, right? Decentralized file system. Something like 80% of it is run by one company, which is how things go, and we would be the ones to maintain it. But if something were to happen, people could revive it. So
Okay,
yeah,
makes
good
sense.
question.
Thanks.
Garrett.
I've got a really dumb question that's not about Bunked, but it's from the other half of the talk where
Yeah, sure.
pretty early in the talk, you were showing like the do ratio breakdown, and you're like, there's some people over here who like hardly ever use their contacts, so they like basically never get a new prescription. And then on the flip side, you have people who wear them forever and like they never renew.
Yes.
That slide. And you were like, this represents these people, this represents these other people. Like, my question, like really basic question is, when you say that, are you hypothesizing which each band represents? Or do you actually know this like 1.5 represents the group of people who have 2 dogs and one of them eats a contact every other week? So they're, you know what I mean? Like you seem like very specific about what those represent. And I'm wondering if you could talk through how you got to that.
Oh, I see what you mean. Well, to your dumb question, I have a dumb answer, which is, so you're saying that this is objective data, right? These are customers who fall into this bucket. These people don't buy their contacts for 2 times as long as the manufacturer would expect. Are you asking whether we are making assumptions about why they do that, or whether we know?
Yeah, like you were making assumptions, but you seemed really confident about like what those people. And so I'm like, oh, maybe
Yeah.
there's more data behind that. And if so, like, what's the brief version of how you got that more clear persona?
I actually am remembering, I kind of have a cool answer to this. So one answer is we have some qualitative research from talking to customers. A lot of it was assumptions. Some of it kind of doesn't matter. It's just like you stretch for whatever reason, and we're going to try to, but some of it helps inform feature engineering. Like I went to the doctor and that's why I skipped an order, right? The cool answer though, that came from our team, and I wish I could claim credit for, is we came up with one of those kitschy quizzes. What type of contact wearer are you? And like people loved it. And they just like, everybody goes on, they're like, oh, I'm the beach guy or whatever. Like I didn't write it, but it gave us so much data on like, oh yeah, I'm the type who wears it, 3 weeks instead of 2 weeks. And it's like, because it was in this kind of fun way, we got so much good data from that. So that really helps inform why some of those patterns happen. A little sneaky data gathering. Thanks.
Yeah, cool. Thank you. It definitely seemed like there was something behind that confidence, and I was really
Yeah.
curious. So thank you.
Yeah, thanks for the question.
Are we good? Any more questions? Oh, we got another one.
So this is going back to Bunked. What would you do in the case where a private key is leaked? And then basically now all of the old images that can be done, you have to find like the point of the leak because people can be uploading things under that
Yeah.
persona.
Yeah. I don't know if I have an answer for that. Our main answer, which is kind of lame, is that we don't want to manage the keys. We want this to be managed by DigiCert here I think they're here in Lehigh. Or also there's a company, Trinsic, that does self-sovereign identity. They're now also local. Because I don't want to deal with that. They already deal in that space, and I don't have a great answer for you, but what we're trying to do is every time something comes out and they're like, hey, we solved this. Here's C2PA, for example, and we're like, oh no, we're done for. We've tried to, instead of thinking that way, like, okay, what are they doing? Can we build on it? Polygon's now doing something with Fox. Maybe we can use their chain instead. Let's think about that. And this is a similar area. It's like we want to do one thing, which is basically just the reverse search. We want to champion that and let people do what they're going to do. So, thanks.
Anything else? Okay, give Cameron a round of applause.
All right. Let's
You're-
throw this up one more time.